Okay, welcome to 4F, the last lesson in our unit. So this lesson is talking about the problem-solving situations for normal distribution. So the bell curve, where do we find a lot of information and where do we find this being used? They use it pretty much everywhere. Any company that creates something, they're always going to have a team that deals with statistical data. They're going to have a frequency range where they want to make sure that that their company basically is going to make the most money. So what they want to do is they want to make sure that if they have a toaster and they say, okay, well, we're going to sell this toaster, but we don't want to give a warranty where everybody's going to bring it back and we have to replace it for free. We want to make sure that our company is going to make the most money. So usually what happens for a company is if they find out that the average toaster breaks down every 5 years, they're going to make sure that their warranty is only under 5 years. Why would they do that? Yeah, to make money. They don't want to have to replace all those free toasters. So that's exactly what's going on here. So this one's talking about a light bulb manufacturer. So this is going to go back to when we've got all of our original equations. So when we're given our original equations to find mean and standard deviation, we are often given information within the question, and sometimes we don't know where the information is useful. So let's take a look and read and label our question. So when we label them, we're looking for items like mean, standard deviation, z-score. We're looking for those numbers, and we're going to label them as such. So first of all, it tells us the total number of light bulbs. Then, from the past data, the lifetimes of the light bulbs, they found a mean of 900 hours. So our mean is 900. And then they found a standard deviation of 50 hours. So basically, every 50 hours is what that graph would go up by. It says, predict the percentage of bulbs that will last between 825 and 875 hours. Label the region of the graph. So if I want to find on this graph, so we need to find out where it would be located. So if my mean is 900, and I'm going up and down by 50s, where are these two numbers located, 825 and 875? Are they to the right of the mean or are they to the left of the mean? They're to the left of the mean. They're numbers that are lower than 900. So because they're numbers that are smaller than 900, that means that their z-scores are going to be negative numbers. Because the minute I turn this number right here, because they're going up by 50s, right? For every number you go up and down by. But the minute I turn that to my z-score table, because I need to have 0 in the middle, so I know my 900 is my mean. But now I need to change that 825 and 875. I need to change those numbers into z-score numbers so that I know where they're located. And then I can find out how much information is shaded between them. Now, right now, all we know is that they are left of 0. They're going to be negative numbers. That's all we know so far. So they're giving us a hint here. They're telling us to find our z-scores. The only way we can find out how much part is shaded is to find the z-score. We have to convert these bottom numbers into our numbers from -5 to +5. That's what we're trying to do. So we use our z-score equation. So the z-score equation, I'm just going to do the work below here. The z-score equation is x minus mean divided by standard deviation. The x value is the value of the raw score data that they're asking us to find the information from. So we have two different z-scores we need to find. We need to find the z-score of 875, and we need to find the z-score of 825. So we always label it as a subscript so that we know which z-score we're finding. You could have labeled it as Z1 and Z2 as well. That's fine. So the first number, 875, minus our mean, 900, divided by standard deviation of 50. Remember, when we're doing questions like this, you always need to solve the top first before you divide. When we do that, we are going to get -25 over 50, which gives us -0.5. So one of our z-scores is at -0.5. The other z-score is 825. we're going to do the same process, subtract the mean, and divide by the standard deviation of 50. So z-score number 2 here is going to be at negative 1.5, is what we're going to find out. Because we're going to get negative 75 over 50 is what it is, negative 75 over 50. And then to divide it, we get negative 1.5. So now when we go up to the top of our question, we're going to put those numbers on our z-score diagram. So now we found out that we have a z-score of negative 0.5, and we have a z-score of negative 1.5. That's the part that is shaded. That's what they want us to find out. And they want us to find out how much data is in that area. So this is where we go to our calculators, and we're going to go normal CDF. So on my calculator, I'm going to hit second bars, number 2. I want to find out how much data is in there. So I'm going to put in negative 1.5 as my lower boundary. My upper boundary is negative 0.5. Now, you could also use shade norm, and I'm going to put that in there in a moment. And we are going to hit enter. And that's going to tell me how much information is in that area. So we know, and we want 4 decimal places. I'm going to go back up here to my question. So it says predict the percent of light bulbs. We want 2 decimal places per percent. But we have to find the area first, which was 0.2417. So the percentage then, when I times it by 100, is 24.17%. That's how many light bulbs are in that range that will last between 825 hours and 875 hours. Now the next question is where we get the application of that. Now it's going to say, well, how many light bulbs does that actually refer to? Out of that whole batch of 35,000 light bulbs. Well, in general, this is where we're going to take our number, and now we multiply it by our probability. So we multiply it by the area number. Not the percent number, the area number. So that means you're taking 35,000 and you're multiplying it by 0.2417. And that's going to tell you how many light bulbs. So that's going to give us, let's just move this over a little bit. That's going to give us 8,459.5. Can I have 0.5 of a light bulb? No. So you should round that down. Just take off the 0.5, literally. Okay, that's all you're doing. Some may round up to 60, but was it 8,460? No. All right, so when we take a look at letter C, determine the probability that the light bulb is going to last less than 920 hours. So we've got to do the same thing. We've got to find z-score, and then we've got to find out where it's located on the graph. So we want 920. So right here where that 825 is, that's where I'm going to put my 920. So I want z-score of 920. So 920 minus my mean divided by standard deviation. So my z-score is going to give me 20 over 50, which is 0.4. And it wants all of the information less than that. So on my diagram, because it wants us to label the region, we put 0 in the middle always. And again, we're on our z-score diagram, so that means on our normal distribution, -5 to +5. And we find 0.4. So I'm going to put 0.4 right there. Now we are going to shade everything less than that. So everything to the left. So everything less than that. Okay? So if it's everything less, what would my left boundary be then? -5. Good. So I need to use my -5 boundary. So we're going to go second bars. number 2, normal CDF. And we're going to go -5, comma, 0.4. Okay? So -5, comma, 0.4. And always we round our area probability to 4 decimal places. So the area that is shaded, is 0.6554. So if that was a percentage, we would times it by 100 and get 65.54%. So that's how many light bulbs would last less than 920 hours. Okay, we're just making it make sense to our situation here. So whenever you're given a question, and it's going to give you a number amount of something, like it gave us our 35,000 light bulbs that was tested, they're going to ask us to use that number eventually. We had to use that number in this question right here for B. They wanted to know how many actual light bulbs were affected. You have to multiply the area total. Okay, the part that you shaded, that's this part right here. You have to multiply that area total by your total. Okay, total amount of objects you have. Okay, next example. We got a flu virus. And it says that the mean duration was 12 days. So we're going to put our mean 12 days and a standard deviation of 3. So some people got better 3 days later, some people got better 3 days sooner. The data is normally distributed, so it's on our bell curve. If you caught the flu virus, determine the probability that it would last longer than 17 days, between 13 and 15 days. So we need to find our Z-scores. That's always our first step. Always Z-scores first. Because we need to know where it is located on the -5 to +5. So Z-score of 17. So 17 minus 12, all divided by 3. That's going to give us 5/3, which is 1.6 repeating. Now, whenever you've got a repeating decimal, and we need to put it into our calculator, you don't round it. You use 3 of the repeating digits. So what we would do for this number to put it in our calculator, because we have to do normal CDF, and it says longer than 17 days. So on our diagram, it wants us to label and shade. So if our mean is 12 days, and we've got 17 days, that would be over here somewhere, it wants to know 17 days or longer. Well, on our Z-score numbers, we found the mean in the middle is 0, and 17 we just found is 1.666. Okay? Now, the outer boundary we're going to use is +5. So, grabbing our calculator, second bars, number 2, and we're going to hit 1.666, comma, 5. Enter. And again, it's a very tiny region of numbers. So we are going to get the area that is shaded. I'm going to put it above so you can see what I'm writing. 0.047856, yada, yada, yada. It runs on forever. So it wants our rounded probability or area. So our rounded area to 2 decimal places is 0.05. That's the probability that you would get the flu and it would last 17 or longer than 17 days. If we wanted the percentage of that, you multiply it by 100. So the probability of you getting the flu that's going to last longer than 17 days with this strain is only 5%. Okay, so you have a better chance of getting better before that. Now we're going to do the exact same thing for between 13 and 15 days. But now we need to have the Z-scores again. So 13 is above 0, it'll be in here somewhere, and 15 will be in here somewhere, and that's the data we're trying to find. But we need to find the Z-scores for them. So that's our very next step. So Z-score of 13, we do the same steps. 13 minus 12 divided by 3 gives us 1/3. Z-score of 15, Gives us 15, subtract 12 over 3, which is 3 over 3, which is 1. So we have another repeating digit, 1/3. So we're going to have 0.333. We have to use 3 of those digits. And the 1. So we go back to our calculator now. And we type it in. If you want, you can hit second enter. It will retype what you just put in. You just retype over the numbers. So my left boundary, closest to 0, is 0.333, comma, 1.0, it's the 1. Enter. So we find the area, which is also known as probability. It doesn't matter which word you use for it. Some refer to it as area, some refer to it as probability. The area and probability for this one is 0.2109119, etc. So it's 2 decimal places, 0.21. So roughly 21% of the data is in between there. All right, last 3 examples. This next one is going to tell us a couple other things. So for our toaster question here, okay, so this one says, from extensive testing, an appliance distribution company knows that the average life of a toasty toasters is 4.2 years. Standard deviation is 0.65 years, and it is normally distributed. The company does not want to replace more than 8% of the toasters that are sold. So they want to save some money and not have a big warranty. So this is our question. What warranty should they offer if they don't want to offer more than 8%? So what we've been given, if we draw our diagram, we've been given this little teeny area. And that little teeny area is 8%, which is 0.08 as an area number. So that's the amount of information we're looking at. They don't want to replace more than this, so we have to have less than this. So is that a Z-score number right now? No, it's a shaded area number. So I need to work backwards. So the first step we need to do here, when given area, find the Z-score. So we have to find the Z-score using inverse norm. So second bar is number 3. So that's our first step. So we're going to do that together over here. So we're going to go second bar is number 3. I'll just clear my screen. Second bar is number 3. And now we want to find the Z-score of that area. So we're going to put in the probability area of 0.08, comma 0, comma 1. Okay, and then we're going to hit enter. That's giving us our Z-score number between -5 and +5. So now we know where it's located on the number line. So we know what's shaded. Now it tells us that the Z-score number is -1.41. So we found the Z-score number, -1.41. Now, if it doesn't want to replace any toasters more than that, we need to figure out what X value gave us that Z-score. So we're working backwards again. So now our second step is going to be to find X, which is the raw data, because we want to find out how many years we can set our warranty at. So we find X, the raw data, given now that we've got the Z-score number, we've got the mean number, and we've got the standard deviation. So we're going to rearrange our Z-score formula. so that we can find the x. So our z-score formula is x minus mean divided by standard deviation. I need to find this original x number. That's going to tell me how many years I need to set my warranty at. Okay, that's what it's looking for. So now, when I rearrange the formula, it becomes this. X equals the mean plus z-score times standard deviation. So now I'm going to input my numbers into where they belong. Mean, z-score, standard deviation. And then we're going to do the math. Okay? So we find x given the raw data. Number 3, rearrange. Z-score formula to solve for x. And that's your very last step. So now we're just plugging our numbers into that z-score formula that we rearranged. So x equals, the question told us we had a mean of 4.2 years, plus, we figured out our z-score is negative 1.41, and we got to times that number by our standard deviation of 0.65. There. Okay, so now we're going to multiply before we add, because we got to do bed mass. So x equals 4.2 plus negative 0.9165. You're adding a negative there. And we get 3.2835. So, to the nearest whole year, how many years should they make their warranty at? To the nearest whole year. 3 years. Good. So, the warranty should be 3 years. Okay, I'm going to give you a minute to get that caught up. Okay, on this question, they give us the probability. They tell us it was found that 62.3% of the shrimp harvest had a mass of more than 135 grams. If the data is normally distributed on a bell curve, and the mean mass was 146, so let's label, and the standard deviation, it wants us to determine standard deviation. Well, I've only been given one number. So, in order to find that out, here's an X number. It says most farms have a mass of more than 135. So we need to know which numbers those are. 135, that's a raw score data number. That's an X number. So the z-score formula has 4 variables. We need to have 3 variables in order to find the 4th. So what number are they giving us that we're able to find? Well, this is similar to the last question where they gave us area first. If they give us the area shaded or the percent probability, all we do is we take our percent and we divide it by 100. That's step 1. So we're going to have 0.623. Okay, that's our probability area. The next step we need to do is we need to find the z-score. The minute I have a probability number, I can find z-score numbers from -5 to +5. So I need to find is z-score number. So in order to do that, I use inverse norm. So second bar is number 3. And we have inverse norm. And we put in our numbers 0.623, comma 0, comma 1. So that's going to give us our z-score number. Once we have our z-score number, we have 3 out of the 4 numbers we need to find the 4th number. So the z-score we find when you use it in your calculator, the number you should find is negative 0.31. So that tells us right now on our diagram, he's about right here at negative 0.31. And the question says, most of them have a mass bigger than that. Well, if we look at the diagram, most of the data is above that. So that makes sense for what we're talking about. So, next we need to rearrange the z-score formula. So, step 3, rearrange z-score formula to solve for standard deviation. And this is the easiest rearrangement because all that happens is z and standard deviation switch places. They literally just switch places. So in the z-score formula, so it looks like this, z equals x minus mean divided by standard deviation. These two literally switch places. So standard deviation is equal to x minus mean divided by z-score. And that's what we're going to do. We're going to use the standard deviation formula. So that's our point right now where we've got to plug the numbers in where they go. So our x raw data number was 135. So we had 135 minus our mean of 146 divided by z-score number we just found, negative 0.31. The top number will become a negative number, and so will the bottom, and that's going to divide to give us a positive. The only numbers that can be negative are the z-score numbers. Every other number you'll deal with will be positive numbers. So this guy is going to be negative 11 divided by negative 0.31, which is going to give us 35.5. So we know that the standard deviation of those fish are every 35.5 grams. Okay? So that's what we were asked to find, the standard deviation. Okay, final question here. The marks of a large number of students have been represented on our graph here. The values given represent the number of students in each area. So this is a question where they don't tell us the total, but we can easily find the total out by the diagram. So how many students are we talking about for a total of students? Aha. Well, if we cut our diagram in half, this is our half right here. How many are on the right-hand side? 1250. So that means 1250 should be on both sides. Now remember, if we want to find Z1, we have to start at the beginning and run the race up to that line. Well, we're not able to do that unless we know how much information's in there. Well, they gave us the 1250 on the right so that we know what number to subtract from. So we're going to take 1250 and we're going to subtract the 452. That's going to tell us the unshaded part. Okay? So 798 is the unshaded. Now, we don't know the probability of it. We need to be able to find the probability so we can use inverse norm. Well, we can easily find the probability because we do know the total. We can figure our total out by taking half and doubling it. 1250 times 2. So our total is 2500. So if I want to find the probability or the area of my unshaded, I will take my unshaded 798 and I'm going to divide it by my 2500. That's going to give me my probability area. And again, we want 4 decimal places when we do that. So we're all going to now divide 798 by 2500, and we're going to get 0.3192. So roughly 32% of the data is over there. So now we need the z-score number for that. That's the whole thing it's asking us for. Letter B wants the z-score number. So we solved letter A. We needed to find this area number in order to find the z-score number. So now on B, we are going to go inverse norm. And we're going to put our probability number in, 0.3192, comma 0, comma 1. And that's going to give us our z-score location. Now we know it's left of 0, so it's got to be a negative number. And again, z-scores are rounded to 2 decimal places, so that's why it's asking for the hundredth. 2 decimal places. So this is going to give us an answer of negative 0.46993, yada yada. So we want 2 decimal places. This 9 is going to round that 6. So that means our z-score is negative 0.47. So if you're given a situation where they give you half of the diagram, they've given you half of the diagram on purpose so that you know the total. Knowing the total, you can find out the probability number, which is important for us here. You put the probability number over the total, okay? And that's going to help us find, in inverse norm, the z-score number. This concludes lesson 4F.